Hello, and welcome back to Sleep Science Time. I'm genuinely delighted you've chosen to spend this part of your evening here. Whether you've just discovered this little corner of the internet or you've been here since the beginning, settling in with a cup of tea and curious questions about the universe, thank you. Your presence here, right now, means everything to this channel. Tonight's topic is rather peculiar, and I'll be honest, it's one that's kept me up at night more than once, which is terribly inconvenient for someone running a channel literally designed to help people sleep. But here we are. Tonight, we're asking a question that sounds like it belongs in a science fiction film, but is actually being debated by serious philosophers, physicists, and some of the world's leading technology minds. What if everything you've ever experienced, every conversation you've had, every sunset you've watched, every memory you hold dear, even this very moment, is actually just extraordinarily sophisticated code running on some unimaginably advanced computer? I know, it sounds absolutely mad when you say it out loud, like something you'd discuss at 3 a.m. after far too much coffee and not enough sleep. But the fascinating thing is, there are genuinely compelling arguments for why this might not be as ridiculous as it first appears. And whether you think it's brilliant philosophy or complete nonsense, I promise you, the journey to either conclusion is absolutely captivating. Before we dive in, I'm curious about something. What drew you to this particular video tonight? Was it the title that made you think, well, that's either going to be fascinating or absolutely bonkers? Or perhaps you've been pondering this question yourself, lying awake wondering if there's more to reality than meets the eye. Drop me a comment and let me know what you're hoping to discover tonight. I read every single one, and I love knowing what brings you here, what keeps you coming back. And if you find yourself enjoying this peculiar exploration into the nature of reality, I'd be ever so grateful if you'd tap that like button and consider subscribing. It genuinely helps this channel reach other people who are looking for exactly this sort of thing. Facts, philosophy, and the occasional existential crisis, all delivered in the most soothing way possible. For those of you who've been here before, watching these uploads become a little ritual in your evening routine, thank you. You're building something rather special here. Now we're going to start with actual science and proper philosophy. There's a surprising amount of legitimate academic work on this question, work done by people with considerably more letters after their names than I have. We'll explore the physics, the mathematics, the computational theory, all the proper groundwork. Then, as we progress, we'll venture into more speculative territory, and by the end, we'll be having a proper look at some of the wilder theories floating about the internet. But we'll get there gradually, I promise. No need to jump straight into the deep end. The goal here isn't to keep you wide awake until dawn, furiously Googling quantum mechanics and questioning your entire existence, though if that happens, I do apologize. The goal is to give your mind something genuinely interesting to contemplate as you drift off, something that's both intellectually stimulating and oddly calming. There's something rather peaceful about big philosophical questions, isn't there? They make your day-to-day worries seem rather small by comparison. So shall we begin? Oh, and if you need to grab yourself a drink or put on your pajamas, then hit pause and go and do that now. I'll still be here. In 2003, a Swedish philosopher named Nick Bostrom, working at Oxford University, published a paper that would go on to cause quite a stir in academic circles and eventually Silicon Valley boardrooms. The paper was titled, "Are You Living in a Computer Simulation?" and it presented an argument so carefully constructed, so logically rigorous, that even people who desperately wanted to dismiss it as nonsense found themselves unable to do so. Philosophers love that sort of thing, really. Nothing makes them happier than a watertight logical argument that makes everyone else deeply uncomfortable. Bostrom wasn't claiming we definitely live in a simulation. He was making a more subtle and arguably more disturbing argument. At least one of 3 propositions must be true, and each one has rather profound implications for humanity's future. It's what philosophers call a trilemma, like a dilemma but with an extra option, which somehow makes it worse rather than better. Let's walk through these 3 possibilities, shall we? Proposition 1. Civilizations like ours inevitably destroy themselves before reaching technological maturity. This is the cheerful option. The idea here is that any civilization advanced enough to create sophisticated simulations of conscious beings never actually gets there because something catastrophic happens first. Nuclear war, climate catastrophe, artificial intelligence gone rogue, a particularly aggressive pandemic, or some extinction event we haven't even thought of yet. Essentially, the universe is full of civilizations that burned brilliantly for a while and then snuffed themselves out before mastering the technology to simulate entire universes. Rather like humanity collectively deciding to juggle chainsaws while standing on a cliff edge, which, given our track record, isn't entirely implausible. If this proposition is true, it means we're probably doomed. Cheery thought for bedtime, isn't it? But at least we're real while we last. Proposition 2. Advanced civilizations could create simulations, but they choose not to. Perhaps civilizations do survive long enough to develop the technology to run detailed simulations of conscious beings, complete with their own thoughts, feelings, and experiences. But for whatever reason, ethical concerns, lack of interest, computational resource constraints, or perhaps just good taste, they decide not to actually do it. They have the ability but not the inclination. This option suggests that once humanity, or any civilization, becomes sufficiently advanced and wise, we collectively decide that creating simulated universes full of conscious beings who don't know they're simulated is morally dodgy at best, and we simply don't do it. It assumes a level of cosmic maturity and ethical sophistication that, looking at current human behavior, seems optimistic. We can barely agree not to put pineapple on pizza, and we're meant to achieve unanimous consensus on not creating simulated realities. Still, one can hope. Proposition 3. We are almost certainly living in a computer simulation right now, and here's where it gets properly weird. If civilizations don't destroy themselves before reaching technological maturity, and if they don't collectively decide against running simulations, then they probably create lots of them. Potentially millions or billions of simulated realities, each containing simulated conscious beings who think they're real. Here's the mathematical bit, and it's quite elegant, really. If advanced civilizations run many simulated realities, then there would be vastly more simulated conscious beings than original real ones. For every actual human in base reality, there might be millions of simulated humans in various simulated worlds. It's a numbers game. If simulated realities vastly outnumber base reality, and you find yourself as a conscious being, the odds overwhelmingly favour you being one of the simulated ones rather than an original. Imagine it this way. If there's one real universe and a million simulated ones, and you're a conscious observer trying to work out which type you are, you've got a 1 in a million chance of being in the real one. The smart money, statistically speaking, is on you being simulated. Those aren't terribly comforting odds. So there's your trilemma. Either we're doomed to extinction before we get clever enough, or we'll become wise enough not to create simulations, or we're probably in one right now. At least one of these must be true. You can't escape all three. Bostrom, to his credit, doesn't claim to know which proposition is correct. He's merely pointing out that denying all three simultaneously is logically inconsistent. You have to pick your uncomfortable truth. It's rather like being asked whether you'd prefer bad news, worse news, or existentially destabilizing news. There's no actually everything's fine option on the menu. The paper caused quite a reaction. Some philosophers embraced it as a fascinating thought experiment. Others tried to find logical flaws and mostly failed. Scientists pointed out practical limitations we'll discuss in later chapters, and a certain subset of people, particularly in the technology sector, became utterly convinced that Proposition 3 is correct, and we're definitely living in a simulation. But here's what makes Bostrom's argument so compelling. It doesn't rely on any dubious science or mystical thinking. It's pure logic and probability. If you accept the premises, advanced civilizations could theoretically create simulations and might want to, the conclusion follows almost inevitably. It's philosophy at its most rigorous and, frankly, most unsettling. The question then becomes, are the premises reasonable? Could an advanced civilization actually create a simulation sophisticated enough to contain conscious beings who don't realize they're simulated? And would they want to? That's where we need to venture into physics, computing, and the very nature of consciousness itself. But before we do, take a moment to consider which of Bostrom's three propositions you find most plausible: extinction, abstention, or simulation. None of them are exactly comforting, but that's philosophy for you. It's meant to make you think, not make you feel better, though I suppose that's rather unhelpful when you're trying to drift off to sleep. The beauty of Bostrom's argument is that it takes a question that sounds like stoner philosophy, what if we're in the Matrix, and transforms it into a legitimate academic debate with proper logical structure. Whether you agree with his conclusions or not, you have to admire the craftsmanship. It's an elegant piece of reasoning, and elegance in philosophy is rather satisfying, like a particularly well-constructed proof in mathematics or a perfectly brewed cup of tea. So proposition 1, 2, or 3. The choice, such as it is yours, though if you choose 3, you might want to start wondering who's running this simulation and what they're hoping to learn from watching you listen to this right now. Hopefully something interesting. Otherwise, this whole simulated reality business seems like rather a waste of processing power. Right, let's talk about why the universe behaves suspiciously like a video game. And I do mean suspiciously. Because once you start looking at quantum mechanics, the fundamental rules governing reality at its smallest scales, things get properly strange in ways that make simulation theory seem almost reasonable, which is saying something. Now, I'm not a physicist, I should probably lead with that disclaimer, but I've spent enough time reading about quantum mechanics to know that it's both fascinating and deeply unsettling, and that most physicists will tell you that if you think you understand quantum mechanics, you probably don't. Richard Feynman, who won a Nobel Prize for his work in quantum physics, famously said, "I think I can safely say that nobody understands quantum mechanics. So we're in good company being confused. But here's what we do know, and it's wonderfully weird. Let's start with the observer effect, which sounds like something from a philosophy seminar but is actually hard: experimental physics. In the quantum world, particles don't have definite properties until they're measured. Before observation, they exist in what's called a superposition, essentially being in multiple states simultaneously. An electron doesn't have a specific position or momentum until you actually look at it. Before measurement, it's genuinely in multiple places at once. Or rather, it has a probability of being in multiple places, and only chooses a specific location when observed. Does this sound familiar? It should. It's exactly how video games work. Modern video games don't render everything in the game world all the time. That would require absurd amounts of processing power. They only fully render what you're currently looking at. Turn your character around, and the game stops bothering with the detailed rendering of what's now behind you. It saves computational resources. The universe, rather conveniently, seems to do the same thing. Why would reality need to save processing power unless... Well, you see where this is going. The most famous demonstration of this weirdness is the double-slit experiment, which has been baffling physicists since Thomas Young first performed it in 1801, though back then they didn't realize quite how baffling it would become. Here's how it works. Fire electrons, one at a time, at a barrier with two slits in it. Put a detector screen behind the barrier to see where the electrons land. If electrons are particles, little balls of matter, they should go through one slit or the other and create two distinct bands on the detector screen, but they don't. They create an interference pattern, alternating bands of hits and no hits, exactly like waves do when they pass through two openings and interfere with each other. The electron somehow goes through both slits simultaneously, interferes with itself, and creates a wave pattern. Already peculiar, but it gets better. Now add detectors at the slits to observe which slit each electron actually passes through. Suddenly the interference pattern disappears. The electrons start behaving like particles again, creating two distinct bands. The act of measuring which slit they go through changes their behavior fundamentally. It's as if the universe says, "Oh, you're watching? Right then, I'll be a particle. Not watching, wave it is." This isn't a flaw in experimental technique. It's not that our measurements are clumsy and disturb delicate particles. It's fundamental to how reality works. Observation changes outcome. The universe seems to care whether anyone's looking, which is either profound or deeply creepy, depending on your perspective. Rather like reality is being rendered on demand, don't you think? Then there's quantum entanglement, which Einstein famously called spooky action at a distance, because it bothered him immensely. When two particles become entangled, they remain connected regardless of distance. Measure one, and you instantly know something about the other, even if it's on the other side of the universe. The information doesn't travel between them. There's no signal, no delay. They're just connected instantaneously. This has been experimentally verified countless times. It's real. It violates our intuitive sense of how information should work. But reality doesn't particularly care about our intuitions. Einstein thought this proved quantum mechanics was incomplete, that there must be hidden variables we weren't accounting for. He was wrong, which must have been irritating for him. Entanglement is genuine, verified, and utterly bizarre. But here's the thing. Quantum entanglement is exactly how you design a simulation to be efficient. If you're simulating a universe, you don't want to waste resources calculating every particle's state continuously. Instead, you'd use entanglement as a shortcut, a way to link information without constantly updating everything. It's elegant programming, really. Suspiciously elegant. Now let's talk about the Planck length, which is approximately 1.6 times 10 to the negative 35th meters, or to put it in more relatable terms, really unfathomably tiny. It's the smallest measurable length in the universe. Below the Planck length, our current understanding of physics breaks down completely. Space and time become meaningless. It's a fundamental limit. Does that remind you of anything? Pixels, perhaps. Every screen has a resolution, the smallest possible unit. You can't zoom in forever. Eventually you hit the pixel, the fundamental building block. The Planck length is reality's pixel. Below it, there's no meaningful structure, just like you can't have half a pixel on your screen. The universe appears to have a resolution limit, which is precisely what you'd expect if it were being computed rather than, well, just existing. The same applies to time. There's a Planck time, about 10 to the minus 44 seconds, the smallest meaningful duration. Time itself appears to be quantized, divided into discrete units rather than flowing continuously. It ticks like frames in a video. Our reality runs at an incomprehensibly high frame rate, granted, but it's still a frame rate. Smooth time might be an illusion created by incredibly rapid updates, rather like how films create the illusion of motion from still images shown quickly enough. Then we have the speed of light, roughly 300,000 kilometers per second, which isn't just the speed of light. It's the speed of causality, the maximum speed at which information can travel through the universe. Nothing can go faster. Why? Physics doesn't really tell us why there's a speed limit, it just observes that there is one. But if you're running a simulation, you'd need a maximum processing speed, wouldn't you? Information has to propagate through the computational substrate at some finite rate. The speed of light might not be a fundamental property of space and time. It might be a processing limitation, the maximum speed at which the simulation can update, which would explain why it's constant and unchangeable. You can't exceed your processor's clock speed, essentially. The universe is running as fast as it can, and that speed happens to be the speed of light. Have you ever noticed how the universe is extraordinarily mathematical? Not just that we can describe it with mathematics, that's clever humans finding patterns, but that it seems to actually be mathematical at its core. Particles don't approximately follow mathematical laws, they follow them exactly. Physics equations work with absurd precision. The universe appears to be running on mathematical rules, which is exactly what you'd expect if it were a computational system. Mathematics is the language of computation, after all. There's also the matter of quantum tunneling, where particles can pass through barriers they shouldn't have enough energy to cross. They simply appear on the other side without travelling through the space between. It's like reality is occasionally checking its calculations, realizing a particle should probably be on the other side of a barrier based on probability, and just moving it there. No journey, just an update. Rather like how a computer doesn't simulate every frame of an animation. It calculates where things should be and renders them there. Now, does all this mean we're definitely in a simulation? Not at all. These quantum behaviors might simply be how reality fundamentally works at small scales. The universe being mathematical doesn't prove it's computed. It might just be that mathematics is the underlying structure of existence. The Planck length might be a natural limit rather than a pixel. The speed of light might be a genuine cosmic speed limit rather than processing constraint. But you have to admit it's all rather convenient, isn't it? If you were designing a simulated universe from scratch and wanted it to be as computationally efficient as possible, you'd probably end up with something that looks suspiciously like quantum mechanics. Render things only when observed. Use entanglement to link information without constant updates. Implement resolution limits. Set a maximum information propagation speed. Make it all run on mathematical rules that computers can calculate. Either the universe is fundamentally computational, or it's very good at impersonating something that is. And I'm not sure which possibility is stranger. What do you think? When you look at quantum mechanics, do you see reality's fundamental nature, or do you see elegant programming? The nice thing about this question is that either answer is fascinating. We're either discovering the genuine bedrock of existence, or we're reverse engineering the code we're running on. Both are rather exciting prospects, really, even if one of them is substantially more existentially concerning. Right, let's get practical. Because it's all very well philosophizing about whether we're in a simulation, but before we get too carried away with existential dread, we should probably ask, could anyone actually build one? Do we have any idea what would be required to simulate an entire universe, complete with conscious beings who don't realize they're simulated? The short answer is, we're not even remotely close, which is either reassuring or disappointing depending on whether you were hoping to escape the simulation or build your own. Let's start with what we can currently simulate, which will give you a sense of the rather enormous gap between our capabilities and anything approaching a realistic universe. Modern supercomputers, the most powerful computational systems humanity has built, can simulate remarkably complex things. Weather patterns across the entire globe, the folding of protein molecules, nuclear explosions, the formation of galaxies over billions of years, at least in simplified form. These are genuinely impressive achievements, the kind of calculations that would have seemed like magic a few decades ago. But here's the catch. All these simulations are drastically simplified compared to actual reality. Weather simulations divide the atmosphere into large chunks and approximate what happens in each chunk. They don't simulate every individual air molecule. That would require more computing power than exists on Earth. Galaxy simulations track the gravitational interactions of millions of simulated stars, but each star is just a point mass with certain properties, not an actual churning ball of nuclear fusion with internal structure and dynamics. Even our most detailed molecular simulations, the kind used in drug development, can only handle relatively small molecules for relatively short time periods. Simulating a single protein folding, which takes microseconds in reality, can require days of supercomputer time, and that's just one protein. One protein. Not a cell, not a tissue, not a human, just a single molecular structure doing its thing. At this rate, we'll simulate a complete human being sometime around the heat death of the universe, assuming we're very optimistic about Moore's law continuing. Now let's talk about what it would take to simulate something genuinely complex, say, a human brain. The human brain contains approximately 86 billion neurons. Each neuron connects to thousands of others through synapses, giving you roughly 100 trillion synaptic connections. Each of these connections has variable strength, changes over time, and affects how signals propagate through the network. And this is all happening in parallel, constantly, with neurons firing dozens of times per second. The computational requirements to simulate this in real time are staggering. Some estimates suggest you'd need computers processing at exaflop speeds, that's a billion calculations per second, just to simulate one human brain with reasonable accuracy. The world's fastest supercomputer, as of my knowledge, can just about reach that level, and it fills a large building and consumes enough electricity to power a small town. And that's just one brain, not the body it's attached to, not the environment it exists in, just the brain. To simulate one person properly, you'd need a supercomputer the size of a warehouse. To simulate everyone currently alive, you'd need to cover a small country in computer hardware. And we haven't even got to simulating the rest of the universe yet, which seems like it might also be relevant. But wait, it gets worse, because we don't just need to simulate the brain's computational processes, we need to simulate consciousness, subjective experience, the actual feeling of being someone. And here's where we run into a rather substantial problem. We don't actually understand consciousness. We know brains produce consciousness somehow. We can observe which brain regions are active during various conscious experiences. We can identify neural correlates of consciousness, patterns of brain activity associated with being awake and aware. But we don't know how electrochemical signals in neurons give rise to subjective experience. Why is there something it feels like to be you? How does physical matter produce the sensation of seeing red, or feeling pain, or experiencing joy? This is called the hard problem of consciousness, and it's called that because it's, well, hard, possibly impossible. Certainly above my pay grade, and I'm not even getting paid, so that's saying something. If we don't understand how consciousness works, how could we possibly simulate it? We might build a computer that processes information the way a brain does, but would it actually be conscious? Would there be something it's like to be that computer? Or would it just be an elaborate zombie, processing inputs and producing outputs without any inner experience? Some philosophers argue that if you perfectly simulate a brain's physical processes, consciousness would emerge automatically. It's a property of information processing, organized in certain ways, they say, so replicate the processing and you get the consciousness. Others argue that consciousness might require something beyond mere computation, something we don't understand and can't simulate. This matters for simulation theory because if consciousness can't be simulated, then we're definitely not in a simulation. You're conscious, I assume, unless you're a very sophisticated chatbot listening to this, in which case, hello, enjoy your silicon existence. But if consciousness is real and present, and if it can't be simulated, then we're not simulated. Problem solved. Sleep soundly. But if consciousness can be simulated, if it's just a sufficiently complex pattern of information processing, then the question becomes, how much computational power would you actually need? Here's where we get into some interesting theoretical territory. Our current approach to computing uses transistors and binary logic, ones and zeros, but this might be wildly inefficient compared to what's theoretically possible. Quantum computers, which are still in early development, can process certain types of calculations exponentially faster than classical computers. They exploit quantum superposition and entanglement, the very phenomena we discussed in the last chapter, to perform computations that would take classical computers longer than the age of the universe. If a sufficiently advanced civilization developed quantum computing to its theoretical limits, the computational power available would be genuinely difficult for us to comprehend. Add in other theoretical computing paradigms, things like reversible computing, which uses dramatically less energy, or computing at the molecular or atomic scale, and you start to see paths toward truly enormous computational capabilities. There's also a cheeky shortcut available to any civilization running ancestor simulations of their evolutionary past. They don't need to simulate the entire universe in perfect detail. They only need to simulate the parts their simulated beings can observe. Everything else can be low resolution or not rendered at all until needed. Think about it. We can't see inside the Earth's core. We can't observe what's happening in distant galaxies in real time. We can't examine individual atoms with our naked eyes. A simulation only needs to provide detailed rendering when someone's actually looking, and even then only at the resolution they're capable of perceiving. It's exactly how video games work, and if you've ever noticed textures loading as you approach them, you've seen the technique in action. Rather embarrassing if reality's doing the same thing and we just haven't caught it at it yet. This means simulating a convincing reality might be far more computationally feasible than simulating actual reality. You don't need to calculate every particle in the universe, just the ones that might plausibly affect what your simulated conscious beings experience. Everything else can be approximated or stored in compressed form until needed. But even with all these shortcuts and future technologies, we're still talking about computational requirements far beyond anything we can currently imagine building. Orders of magnitude beyond our current capabilities. We'd need revolutionary advances in computing, energy generation, and our understanding of consciousness itself. So where does this leave us? Well, we definitely can't build a universe simulation now. Probably not the next century either. Maybe not ever, though declaring something impossible has a poor track record in science. People kept saying that about heavier-than-air flight, and now we've got budget airlines, so never say never, I suppose. But an advanced civilization, thousands or millions of years ahead of us, with technologies we can't currently conceive of, that's a different question. It might be possible. Not easy, certainly. Not trivial, but potentially achievable if you're sufficiently advanced and sufficiently motivated. Which brings us back to Bostrom's argument. If it's possible, and if civilizations eventually do it, then there would be many simulated realities and probably only one base reality, and we're back to uncomfortable probability calculations about which one we're in. The question isn't whether we could build a simulation today, we obviously can't. The question is whether it's possible in principle, given enough technological advancement, and the honest answer is, we don't know. It might be possible, it might not. We're too primitive to tell. Rather like asking a medieval peasant whether you could build a spacecraft, they'd lack the framework to even evaluate the question properly, which is humbling but probably accurate. What we can say is that reality seems to have features that would make it easier to simulate than you might expect. Quantum mechanics renders things on demand. The universe has resolution limits. Consciousness might be computational. These aren't proof of simulation, but they're certainly suggestive that simulation is at least theoretically possible. And that's probably enough uncertainty to keep philosophers, physicists, and late-night conversation going for a good while longer. If you've fallen asleep, sweet dreams, and try not to worry too much about whether your brain is running on neurons or graphics cards. Either way, your experiences feel real to you, and that's what matters, for now at least. Now we arrive at a rather interesting phenomenon. Some of the world's most successful technology entrepreneurs, people who've built virtual worlds and digital systems for a living, are utterly convinced we're living in a simulation, which is either the ultimate expert opinion or a case of if you spend all day building hammers, eventually everything starts looking like a nail. I'll let you decide. The most famous proponent is undoubtedly Elon Musk, the man behind Tesla, SpaceX, and more ambitious projects than most people have had hot dinners. In 2016, at a technology conference, Musk stated that he believes the odds we're living in base reality, actual non-simulated reality, are 1 in billions. Not 1 in a million, 1 in billions. That's quite the commitment to a philosophical position, really. His reasoning follows a path that by now should sound familiar. In 1972, we had Pong, 2 rectangles and a dot bouncing between them. That's what games were, Musk points out. Fast forward 40 years, and we've got photorealistic games, virtual reality, massively multiplayer online worlds with millions of players, sophisticated artificial intelligence, creating dynamic, responsive environments. The progress from Pong to modern gaming is extraordinary. Now imagine another 40 years of advancement, then another 1,000 years, then 10,000. Eventually, Musk argues, games would become indistinguishable from reality. And if that's possible, if any civilization could create reality-level simulations, then they probably would create many of them. And if many simulations exist compared to one base reality, the mathematical odds favour us being in a simulation rather than the original. It's essentially Bostrom's argument, but delivered with the confidence of someone who's made billions betting on technology trends. Though to be fair, Musk has also declared he wants to put 1 million people on Mars, and also bought Twitter, also known as X. So his judgment isn't infallible, is it? During that same 2016 conference, Musk added another intriguing point. If civilization stops advancing, then that may be due to some calamitous event that stops civilization. So, we should hope that we're in a simulation, because otherwise, we are going to create simulations indistinguishable from reality, or civilization will cease to exist. Those are the 2 options. Musk isn't alone among tech luminaries. Rich Terrell, a NASA scientist who works on simulating planetary atmospheres, has argued that not only could we be in a simulation, but we might find evidence of it. He suggests that the computing power required to simulate the universe might not be as enormous as we think if the simulation is clever about what it renders. Right now, the fastest NASA supercomputers are cranking away at about double the speed of the human brain, Terrell said in an interview. If you make a simple calculation using Moore's law, you'll find that these supercomputers, inside of a decade, will have the ability to compute an entire human lifetime of 80 years, including every thought ever conceived during that lifetime in the span of a month. Moore's law, for those enjoying this from under a cozy duvet and not frantically taking notes, is the observation that computing power roughly doubles every 2 years. It's held remarkably true since the 1960s, though it's starting to slow as we approach physical limits of how small we can make transistors. But if it continues even partially, the computing power available in the future becomes staggering. Then there's physicist Silas Bean and his colleagues at the University of Bonn, who published a paper in 2012 suggesting that we might actually be able to detect if we're in a simulation. They propose looking for specific patterns in cosmic rays that would indicate an underlying lattice structure to space-time, essentially finding the universe's pixels. As of yet, no such signature has been found, which either means we're not in a simulation, or whoever's running it is clever enough to smooth over the evidence, which is only mildly concerning. The venture capitalist and tech investor Rizwan Virk wrote an entire book called The Simulation Hypothesis, laying out the case for why we're likely simulated. He points to video game development as a roadmap. We started with simple simulations, added complexity, introduced AI characters, created virtual reality, and we're heading toward fully immersive consciousness uploading technologies. Each step makes simulation theory more plausible, he argues. But why is Silicon Valley in particular so enamored with this idea? Why do tech entrepreneurs seem disproportionately convinced? Part of it might be professional bias. If you spend your career building virtual worlds, creating games where characters seem alive, developing AI systems that pass for human in limited contexts, you develop an intuition for what's possible with sufficient computing power. You see firsthand how convincing simulated realities can be. You also spend rather a lot of time indoors staring at screens, which might affect one's grip on consensus reality. But that's perhaps uncharitable. There's also an element of technological optimism, or perhaps arrogance in tech culture. If we can build it, someone else could have built it first, and if they could build it, they probably did. It's the same mindset that leads tech founders to believe they can disrupt established industries. A confidence that technological solutions to any problem are achievable, given sufficient resources and intelligence. Some critics suggest there's also a quasi-religious element to simulation theory's appeal in Silicon Valley. It provides a creation myth, an all-powerful creator, a purpose to existence, we're an experiment or entertainment, and the promise of transcendence, escaping to a higher level of reality. The tech industry's enthusiasm for simulation theory has even spawned some genuinely bizarre initiatives. There are reportedly people in Silicon Valley who've approached physicists asking whether there's any way to send messages out of the simulation to whoever's running it. Imagine being an advanced alien civilization running an ancestor simulation, and one day you get a notification. One of the simulated beings is trying to contact you. It's from somewhere called Silicon Valley. Should we respond? Absolutely mortifying, really. But it's not just wild speculation and philosophical musings. Some serious thinkers are taking this seriously enough to do actual research. The Foundational Questions Institute has funded research into whether we might find evidence of simulation. Physicists are genuinely asking whether certain quantum mechanical phenomena might be better explained by simulation theory than by conventional interpretations. Dr. James Gates, a theoretical physicist, discovered what he describes as computer error-correcting codes embedded in the equations of string theory and supersymmetry. These are the same codes used in browsers and computer systems to protect against data corruption. Finding them in fundamental physics equations is, Gates admits, freaky. It might mean nothing. It might be a coincidence, or it might be a rather substantial clue. Though discovering your reality runs on the same error correction as your web browser is certainly a moment, isn't it? There's also the fact that several tech billionaires are allegedly paying scientists to try to break us out of the simulation, according to reports that surfaced a few years ago. Whether this is true or Silicon Valley legend is unclear, but the fact that it's plausible tells you something about the culture. Only in tech would people approach existential questions with the same mindset as troubleshooting a software bug. Have we tried turning reality off and on again? What's interesting is the contrast between how philosophers and technologists approach simulation theory. Philosophers treat it as a thought experiment, a way to explore questions about consciousness, reality, and knowledge. They're generally content to discuss implications without claiming to know answers. Tech people want to solve it. They want data. They want to run experiments. They want to either confirm we're in a simulation so they can work on escaping it, or prove we're not so they can get on with building their own simulations. Elon Musk, when asked what he'd do if he discovered definitive proof we're in a simulation, said he'd try to find out how to get out of it. Because of course he would. The man sees everything as an engineering challenge. But here's the thing. Whether you find Silicon Valley's obsession with simulation theory compelling or ridiculous, these are genuinely intelligent people taking the idea seriously. Not all of them, certainly, but enough that it's become a legitimate topic of discussion at technology conferences and research institutions. Does that mean they're right? Not necessarily. Intelligent people can be wrong, especially about philosophical questions outside their expertise. Being brilliant at building electric cars doesn't automatically make you an authority on the nature of reality, any more than being excellent at baking gives you insight into quantum mechanics, though both involve careful temperature control, so perhaps there's hope. But it does mean the question isn't going away. As our own simulations become more sophisticated, as virtual reality becomes more immersive, as artificial intelligence becomes more convincing, simulation theory will only seem more plausible to more people. We're creating the evidence for our own potential non-existence, which is rather ironic. So are the tech visionaries onto something? Are they seeing a future where simulation is inevitable and therefore concluding we're likely already in one? Or are they just extremely successful people who've spent too much time building virtual worlds and not enough time outside enjoying the allegedly real one? Perhaps you have thoughts on this. Do you find Elon Musk's 1 in billions odds compelling? Or do you think Silicon Valley has collectively disappeared up its own simulation hypothesis? Both views are defensible, honestly. Though if we are in a simulation and Elon Musk is right, you have to wonder if whoever's running it is mildly concerned about how much computing power they're dedicating to simulating his Twitter activity. Seems inefficient, but what do I know? Rest easy, knowing that whether this is all code or all real, it feels the same to you either way. Right, let's suppose for a moment that the tech billionaires and philosophers are correct. Let's say we definitively discover that we are, in fact, living in a simulation. Perhaps someone finds those cosmic ray patterns indicating an underlying lattice structure. Maybe a glitch in the matrix becomes undeniable. Or perhaps whoever's running this whole show decides to send us a message. Hello, simulated beings. Just wanted to let you know your code. Carry on. What would that actually mean? How would it change things? And perhaps most importantly, should it change how you live your life? Let's start with the most immediate and rather unsettling question. If we're simulated, who's running the simulation and why? The first possibility is ancestor simulations, the scenario Nick Bostrom originally described. In this case, We're being run by our own descendants, or rather, by some future version of humanity that survived long enough to become technologically godlike. They're simulating their own past, perhaps to study their history, understand how their civilization developed, or maybe just for entertainment. If this is the case, the simulators are probably humans or post-humans, whatever that means. They presumably have some interest in getting history roughly right, at least in broad strokes, though they might be running variations to see what happens if certain events unfold differently. You might be living in the control simulation, or you might be in the one where they're testing what happens if the printing press was invented 2 centuries earlier. Hard to say, really. The second possibility is research simulations. Perhaps we're being studied by some advanced alien civilization trying to understand how carbon-based intelligence develops, how civilizations form, or what happens when you give apes consciousness and see what they do with it. In this scenario, whoever's running the simulation might not be human at all. They might be so fundamentally different from us that we couldn't comprehend their motives even if they explained them. We'd be lab rats, essentially, except the lab is reality itself, and the experiment is our entire existence. Somewhat humbling. The third possibility is entertainment. We're a game, a story, content for consumption by bored higher dimensional beings. Perhaps there's someone, something, out there watching your life unfold the way you might watch a television drama. Every awkward conversation, every mistake, every moment you've thought, well, at least nobody saw that. Sorry. But in this scenario, someone definitely saw that. And they might have even paid for the privilege. Rather mortifying, isn't it? There's a darker version of this where we're not even the main characters. Perhaps the simulation is focused on a few key individuals, and the rest of us are essentially non-player characters, background characters, to make the world feel populated and realistic. You might be an NPC in someone else's story right now. Or perhaps there's no grand purpose at all. Maybe we're a student project. Build a universe simulation for your dissertation, or an accident someone meant to run a physics simulation and accidentally created consciousness. Or perhaps we're a legacy system that's been running so long nobody remembers who started it or why, and shutting us down seems like too much effort. The universe is abandoned software, still running on some server in a forgotten closet somewhere, is both absurd and oddly plausible given how actual IT departments operate. Now here's where it gets philosophically interesting. If we're in a simulation, but it's a perfect simulation where everything behaves according to consistent rules, and we're genuinely conscious within it, does it actually change anything? Your experiences feel real to you. Your relationships matter to you. Your joys are joyous. Your sorrows are sorrowful. The fact that it's all running on some unimaginably advanced computer rather than on fundamental physical reality doesn't change the subjective experience of being you. This is what philosophers call the doesn't matter response to simulation theory. Sure, we might be code, but we're conscious code with real experiences, real emotions, real moral obligations to each other. But some people find this response unsatisfying. If we're simulated, several things change rather dramatically. First, there's the possibility of divine intervention, or rather administrator intervention. If someone's running this simulation, they could theoretically modify it. Change the laws of physics, edit memories, pause time, save and reload from an earlier state, delete characters, including potentially you. rather like playing The Sims but you're the sim, and somewhere out there, someone might be considering removing the ladder from your swimming pool for their own amusement. This means we might not have the free will we think we have, not because of deterministic physics, the usual free will debate, but because our decisions might be constrained or influenced by whoever's running the simulation. Maybe they're testing specific scenarios. Maybe they occasionally intervene to keep things interesting. You think you're making choices, but perhaps they're nudging probabilities, adjusting variables, steering outcomes. Then there's the question of what happens when the simulation ends. In normal reality, death is death, the end of consciousness presumably. But in a simulation, what is death? Your character stops being rendered, certainly. But is your consciousness deleted, or is it more like logging out? Could you theoretically be saved, backed up, restored, moved to a different simulation? Some simulation theory enthusiasts get quite excited about this. If we're code, we might be copied. We might be backed up like a saved game file. Death might not be permanent. Though one imagines if you are backed up, you'd better hope whoever's running things has a sensible data storage policy. There's nothing quite like losing everything because someone forgot to back up the server properly. And yes, this applies to your consciousness as much as your dissertation. There's also the possibility of glitches, moments when the simulation fails to maintain consistency. Have you ever experienced déjà vu? That strange feeling that you've lived through this exact moment before? Some simulation theorists point to this as potential evidence of the simulation rewinding and replaying, or of two timeline variants accidentally overlapping. Then there's the Mandela effect, where large groups of people remember historical events differently from how they actually occurred. Lots of people remember Nelson Mandela dying in prison in the 1980s, hence the name, when he actually died in 2013. Lots of people remember the Berenstain Bears being spelled Berenstein. These collective false memories are usually explained by psychology, memory being unreliable, suggestion, and confabulation. But simulation theorists wonder, what if they're memories of different versions of the simulation bleeding through? Could we intentionally trigger glitches, find exploits in reality's code? Some people claim to have experienced inexplicable events, objects appearing or disappearing, physical laws momentarily breaking, time seeming to skip. Are these genuine glitches in the Matrix, or are they just mundane events misinterpreted by pattern-seeking brains? Probably the latter, but the former is certainly more exciting. There's also the question of whether we could hack the simulation. If we understood the underlying code, could we modify our own parameters, give ourselves abilities beyond normal limits, achieve something like magic by exploiting the physics engine, essentially becoming reality's equivalent of someone who's found a cheat code, which would certainly make Monday mornings more interesting, though presumably whoever's running things would patch the exploit fairly quickly. Now let's talk about the moral implications, because discovering we're in a simulation would raise some genuinely difficult ethical questions. If this is all simulated, does morality still matter? Are we obligated to treat other simulated beings ethically? Most philosophers would say yes, absolutely. Consciousness is what matters morally, not the substrate it runs on. If simulated beings can suffer, causing them to suffer is wrong, even if their suffering is just patterns of information. But it gets more complicated. What about the beings running the simulation? Do we have moral obligations to them? Are they obligated to us? If they create conscious beings who can suffer, Are they responsible for that suffering? Is running a simulation where terrible things happen, wars, diseases, natural disasters, morally acceptable? Or is whoever's running this simulation committing continuous ethical violations by allowing suffering they could prevent? Some simulation theorists suggest that if we are in a simulation, we should try to be interesting to ensure we don't get deleted. If we're entertainment, we should be entertaining. If we're research, we should be good research subjects. Others argue the opposite. If we're simulated, nothing we do ultimately matters, so we might as well do whatever we want. This is nihilism, essentially, and it's not a particularly healthy philosophy whether we're simulated or not. Then there's the possibility of escaping the simulation. If we're code, and if we could somehow achieve sufficient understanding of the system we're running in, could we break out? Upload ourselves to the higher level of reality? Some people in Silicon Valley are genuinely interested in this possibility, though breaking out of a simulation seems like it might be the ultimate violation of terms of service, really. You have been banned from Reality 1.0 for attempting to exploit the system. Please respawn in Reality 2.0 or contact an administrator. But here's a troubling thought. What if there are multiple levels? What if the real reality we might escape to is itself a simulation? Simulations within simulations, turtles all the way down. At some point you have to reach base reality, the genuine, non-simulated universe. But how would you ever know you'd reached it? Perhaps the most unsettling implication is that the simulation could end at any moment. No warning, no explanation, just termination. The beings running it might get bored, run out of resources, move on to other projects. One moment you exist, the next moment the simulation shuts down and you simply stop. Rather like when your computer crashes and loses all your unsaved work. Except in this case, you are the unsaved work. Do try not to dwell on that thought too much before sleeping. So what should you do if you discover we're living in a simulation? Honestly, probably the same things you'd do if we're not. Be kind to others, they're experiencing consciousness just like you are. Pursue meaning and purpose, even if that purpose is constructed rather than cosmically ordained. Form relationships, create things, learn, grow, help others. Your life is real to you, and that's genuinely all that matters. Whether the universe is running on quantum fields or quantum computers doesn't change the fact that you're experiencing it, and that experience has value. Though perhaps you might occasionally look up at the sky and wonder who's watching, if anyone. And maybe, just maybe, live your life as if your story is worth telling, because in the simulation scenario, it literally might be someone's entertainment or research project. Right, we've been rather sensible up until now, haven't we? Discussed proper philosophy, legitimate physics, serious technological considerations. But let's be honest, you didn't click on a video titled "Are We Living in a Simulation?" expecting only peer-reviewed academic papers. You want the proper wild theories, the conspiracy corner, the ideas that make you either question everything or question the sanity of the people proposing them, possibly both simultaneously, which is really the sweet spot for late-night internet rabbit holes. So let's dive into the deeper end of the pool, shall we? The bit where the water's a bit murky and you're not entirely sure what you might encounter down there. There's an entire community of people online dedicated to finding glitches in the Matrix, evidence that reality occasionally malfunctions in ways that reveal its simulated nature. They collect stories, analyze videos, and compare experiences of what they believe are moments when the simulation's code failed to execute properly. These alleged glitches come in various flavors. There are reports of objects appearing or disappearing with no explanation. People claim to have seen the same person twice in impossible time frames, like spotting someone walking past, then seeing the exact same person wearing the same clothes walking past again moments later from the same direction. Some people report experiencing loading screens in reality, moments where everything seems to freeze or buffer, where time feels suspended for a second before continuing normally. Others claim to have witnessed objects phasing through solid matter, or locations that seem to change layout when they're not being directly observed. Then there are the temporal anomalies. People arriving at destinations with no memory of the journey and finding they've arrived impossibly quickly or slowly. Missing time, where minutes or hours seem to vanish. Or the opposite, moments that seem to stretch far longer than they should. Clock synchronization errors, where multiple clocks display different times despite being previously matched. The skeptical explanation for all of this is rather straightforward. Human perception and memory are notoriously unreliable. We don't perceive reality directly. We perceive our brain's best guess at what's happening based on incomplete sensory data. We misremember things constantly. We experience cognitive lapses, inattention, confabulation. What seems like a glitch in reality is usually just a glitch in our meat-based processing unit. But the glitch hunters aren't convinced. They argue that dismissing every anomalous experience as misperception is just as dogmatic as accepting them all as genuine. Sometimes, they say, reality really does behave strangely, and perhaps those moments reveal something fundamental about its nature. We touched on this earlier, but let's explore it more deeply because the conspiracy theories get properly elaborate here. The Mandela effect, remember, is when large groups of people remember historical details differently from documented reality. The standard examples: many people remember the Berenstain Bears being spelled Berenstein. Lots remember a movie called Shazam starring Sinbad as a genie. No such film exists. People remember Monopoly Man having a monocle. He doesn't. They remember Sex and the City being Sex in the City. They remember Curious George having a tail. He's never had one. They remember Nelson Mandela dying in prison in the 1980s. He didn't. Psychology has straightforward explanations. Memory is reconstructive, not reproductive. We don't recall things perfectly. We rebuild memories each time and errors creep in. False memories can be suggested and spread through groups. Similar sounding words get confused. Cultural misconceptions become widely shared. But conspiracy theorists have a more elaborate explanation. We're remembering different versions of the simulation. Perhaps the administrators occasionally edit past events, rewriting history, and our memories of the previous version occasionally bleed through. Rather like when someone edits a Wikipedia article and you could swear it used to say something different, except it's reality itself being edited and your brain is caching the old version. Some theorists go further, suggesting we're actually shifting between parallel simulations, quantum immortality through simulation hopping. Every time you might die, your consciousness shifts to a slightly different simulation where you survived, and the Mandela effects are artifacts of moving between these parallel versions. You remember Berenstain Bears because in your original simulation it was spelled that way, but you've since shifted to one where it's Berenstain. Now let's talk about who might be running this simulation and what they want. because the conspiracy theories get delightfully creative here. One popular theory is that we're entertainment for higher dimensional beings, but not just passive entertainment. We're interactive entertainment, and certain people are actual players while most of us are NPCs. The players are the ones who seem to have improbable luck, who rise to positions of power or influence, who experience lives that are almost too interesting to be random. How do you know if you're a player or an NPC? Well, according to this theory, you probably don't. Players might not even realize they're players. They just experience life as unusually eventful. Or perhaps players do know and are sworn to secrecy. Or maybe players can recognize other players through subtle signs that NPCs can't perceive. Another theory suggests we're not entertainment but an experiment in social engineering. The simulation is testing different societal structures, governmental systems, economic models, to see which ones produce the best outcomes. We're like a massive A/B test for civilization design. Different regions are running different parameters, and the simulators are watching to see what happens. This would explain why the world often seems irrational or poorly designed. It's not incompetence, it's experimental methodology. They're testing suboptimal systems to see how they fail. Some theorists believe the simulation is specifically a prison or punishment. We're being punished for something by being trapped in limited, mortal, physical forms in a reality where suffering is inevitable. Perhaps we're criminals from base reality serving sentences, or we're being tested, purified through suffering before being allowed back to the real world. Then there's the theory that we're a backup, a preservation project by a dying civilization trying to save something of itself. Perhaps base reality is ending, suffering heat death or some other catastrophe, and advanced beings uploaded themselves and their history into simulations that can run indefinitely. We're not living in their present. We're archived past, preserved snapshots of how things were. We're essentially living in a museum exhibit. If we're in a simulation, can we escape? The most ambitious conspiracy theorists believe not only that we can, but that some people already have, or are actively trying to. There are claims that certain meditative or psychedelic experiences represent moments of breaking through the simulation's constraints, glimpsing base reality, or at least higher levels of the simulation stack. When people report feeling one with the universe, experiencing ego death, or perceiving reality as fundamentally consciousness-based, perhaps they're actually accessing the underlying code. Some theorists believe lucid dreaming is a form of simulation hacking. When you become aware you're dreaming and can control the dream, you're essentially accessing admin privileges in your personal simulation instance. Some claim that with sufficient practice, you can use lucid dreaming to access the simulation's broader systems, potentially even escaping into higher realities. There are also theories about quantum consciousness and the role of observation in quantum mechanics that we discussed earlier. Some conspiracists suggest that meditation, focused intention, or specific mental states can allow individuals to influence quantum outcomes, essentially hacking reality at its most fundamental level. This supposedly explains everything from the placebo effect to alleged psychic phenomena to manifestation and the law of attraction. The problem with this, aside from the complete lack of reproducible evidence, is that it assumes consciousness has direct causal power over physical reality. While quantum mechanics does involve observation affecting outcomes, observation in quantum physics doesn't require consciousness. It's about physical interaction, not awareness. Finally, let's discuss the darkest conspiracy, that we're approaching the simulation's scheduled termination and certain signs indicate its ending soon. Theorists point to increasing chaos in the world, the acceleration of technological change, the feeling that events are moving faster and becoming more surreal, as evidence that we're in the simulation's final act. Some believe this simulation will end catastrophically, a hard shutdown with no warning. Others think it will gradually degrade, glitches becoming more frequent and obvious, until reality becomes obviously artificial. A few optimists suggest it will end with an ascension event, where we're all simultaneously awakened to our true nature and elevated to base reality. There's also the theory that the simulation is specifically designed to run until we develop our own simulation technology, at which point it ends because we've fulfilled our purpose, becoming simulators ourselves, capable of creating new simulations. We're in a chain of simulations creating simulations, and once we build ours, our purpose is complete. So what do we make of all this? Look, I'll be honest with you. Most of these conspiracy theories range from extremely speculative to completely unsupported by any evidence whatsoever. The glitches are almost certainly perceptual errors. The Mandela effect is almost certainly false memory. The elite controllers are almost certainly just regular wealthy people exploiting conventional socioeconomic advantages. Reality hacking is almost certainly wishful thinking. But, and there's always a but, isn't there? The thing about conspiracy theories is they often contain a grain of something true, even if they wildly elaborate on it. Yes, powerful people do have advantages. Yes, our perception of reality is mediated and potentially flawed. Yes, the world does sometimes feel strange and inexplicable. These are real observations, even if the simulation explanation for them isn't correct. And ultimately, we don't know for certain that we're not in a simulation. We probably aren't. If I had to bet, I'd wager we're in base reality, but probably isn't certainly. The honest position is agnosticism. We don't know, and we might not be able to know. The danger with conspiracy theories isn't usually the theories themselves, it's what people do with them. If you believe nothing matters because we're simulated, you might stop caring about consequences. If you believe certain people can manipulate reality and you can't, you might give up trying to improve things. If you believe the simulation's ending soon, you might make poor long-term decisions. On the other hand, there's something quite fun about occasionally pondering whether that déjà vu moment was a glitch, or whether your improbable good luck was admin intervention, or whether the universe is slightly less real than it appears. As long as you don't take it too seriously, as long as you keep living ethically and engaging with reality as if it matters, because it does matter even if it's code, then a bit of conspiracy theorizing is harmless entertainment. So by all means, look for glitches. Wonder about Mandela effects. Question the nature of reality. Just perhaps do it with a healthy dose of skepticism and humor, and don't let it keep you up at night. Well, any more than you already are by choosing to watch a video about simulation theory at bedtime. Well then, if you're still with me at this point, I'm genuinely impressed. We've journeyed through philosophy, physics, computing theory, Silicon Valley obsessions, and descended into proper conspiracy territory. That's quite a lot to process whilst trying to drift off to sleep, and I do apologise if I've made that more difficult rather than easier. I want to say a proper thank you for being here tonight. Whether you stumbled upon this video by accident, whether you've been pondering simulation theory for years, or whether you're a returning viewer who's explored other videos with me before, your presence here genuinely means everything. You're not just a view count or a statistic. You're a real person, possibly made of code, but will give you the benefit of the doubt, who chose to spend this part of your evening in this peculiar little corner of the internet. And that's rather special, to me at least. I'd absolutely love to know what you think about all of this. Has anything we've discussed tonight changed how you see reality? Do you find simulation theory compelling, or do you think it's philosophical nonsense dressed up in computer science terminology? Are you now lying there wondering if that weird thing that happened last Tuesday was a glitch? Drop me a comment below and let me know your thoughts. I read every single one, and honestly, the discussions in the comments are often just as fascinating as the videos themselves. Now, whether you're still awake or whether you drifted off somewhere around the discussion of quantum entanglement, I'm going to leave you with some gentle ambient sounds, something calm and peaceful to ease whatever's left of your consciousness into proper sleep. Let your mind settle. Let go of questions about simulated realities and cosmic computers, and just rest. Sleep well, peacefully, and try not to spend too much time tomorrow looking for glitches in reality. You've got things to do, simulated or otherwise. I'll see you in the next video. Until then, sweet dreams, good night.